Hello everyone. In this video we are going to solve the problem number 1.56 from Irodov, and that is related to kinematics. So let us first understand the problem and then we will solve the problem step by step. A solid body rotates with angular velocity of omega is equal to at I cap plus bt square j cap. So let us say this is a solid body and we are having x-axis and y-axis, and these I cap and j cap both are unit vectors along x and y axis respectively. The angular velocity of this particular body is given as omega vector is equal to at I cap plus bt square j cap. Here the value of a and b are given, so let us substitute it here. So we will get 0.5 t I cap plus 0.060 t square j cap. So this is the angular velocity vector. And in the problem A, it is asking to find the modulus of angular velocity and angular acceleration at the time moment of t is equal to 10 seconds. So if we write the angular velocity vector at the time moment of t is equal to 10 seconds, then we can write it as 0.5 into 10 I cap plus 0.060 into 10 whole square into j cap. So from here we will get 5 I cap plus 6 j cap. So if we find out the magnitude of the angular velocity at the time moment of 10 seconds, then we can write 5 square plus 6 square under root, because both are mutually perpendicular to each other. So 25 plus 36 under root, that is equal to under root 61, and under root 61 is 7.81 radian per second. Okay, now let us talk about the angular acceleration at the time moment of t is equal to 10 seconds. In order to find the angular acceleration, let us denote it as beta vector is equal to derivative of angular velocity. We can write d by dt of what is angular velocity, that is 0.5 t I cap plus 0.060 t square j cap. So we can write 0.5 t I cap plus 0.060 t square j cap. Okay, so if we differentiate here, 0.5 is constant and the differentiation of t is 1. So we can write 0.5 I cap plus differentiation of t square is 2t. So from here we will get 0.120 t j cap. Okay, now if we find the angular acceleration vector at the time instant of t is equal to 10 seconds, then we can write 0.5 I cap plus 1.2 j cap, and we can find out the angular magnitude of the angular acceleration at the time moment of 10 seconds is equal to 0.5 whole square plus 1.2 whole square under root. So from here we will get 1.3 radian per second square. Now in the second part of the problem, it is asking to find the angle between the vectors of angular velocity and the angular acceleration at that moment. So at t is equal to 10 seconds, we are having the angular velocity of omega vector is equal to 5 I cap plus 6 j cap, 5 I cap plus 6 j cap, and angular acceleration vector is equal to 0.5 I cap plus 1.2 j cap. So if we write the cos theta, the angle between these two vectors, so that we can write it as omega vector dot vector with beta vector whole divided by omega vector modulus into beta vector modulus. Okay, so that is equal to 5 I cap plus 6 j cap dot product with 0.5 I cap plus 1.2 j cap whole divided by magnitude of the angular velocity that we have found out here, that is 7.81 radian per second. So this is 7.81 multiplied with angular acceleration at the time moment of t is equal to 10 seconds, that is 1.3 radian per second square. So if we take the dot product here, we will get 2.5 plus 7.2 whole divided by 1.3 into 7.81. So from here we will 0.955. Okay, so from here we can find out theta is equal to cos inverse of 0.955. So that is equal to 17.25 degree. Okay, so I hope the entire procedure is clear. We have found out the angle between the angular velocity vector and the angular acceleration vector, and we have also found out the at the time moment of t is equal to 10 seconds what is the modulus of angular velocity and the modulus of angular acceleration. Thank you.